Which one of these is it?
Okay, my friends, here we go. We are ready for number 12. Okay, so let's go. Oh, this is an inequality now. An inequality, so pay attention to that. Anybody remember how to start? Ay. Start?
Get rid of, or like factor out a cosine?
Factor. No. I'm not gonna factor out anything, but I am going to factor it. Right, there is no GCF in the problem, but I can do this, alright? I hope I can anyway. Does that seem okay? Alright, so that says cosine is 1/2, or cosine is 1. Now it's an inequality, so there's going to be some shading involved. I think most of you ended up liking the unit circle shading, but you could also draw a cosine curve and shade that. It doesn't matter, but we have to shade something. So here's my unit circle. There are going to be two important angles on this unit circle. One is going to be where the cosine is 1/2. Cosine is x, and the cosine will be 1/2 here and here. Would you agree with that? Here's where the cosine is 1/2. What are those angles? The angles where the cosine is 1/2, that would be pi over 3 and 5 pi over 3. All right, so let's get those on there. Then, we're going to have another important angle where the cosine is 1. Where is the cosine 1? 0. So this place right here, this is the only place. I'll go ahead and draw in my line, but I don't need it. That's where the cosine is 1. Okay, so now, this was an inequality. A greater than. I am multiplying these two factors together, and I have to be greater than. So what does that mean about my factors? If I need to be greater than 0, then my factors are either both positive, so they're both greater than positive, or they're both less than negative. Would you agree with that? So if they are both greater than, then that means I have to be to the right, talking about x's, cosines, going this way, I have to be greater than my black line, and I have to be greater than my green line. So I'm shading here, and I really don't need to shade except the point itself. So what would be, if I went that way, but with both of them, what would be bigger than black and bigger than green? Just 0. So the answer to this bigger than is just 0. Now what if I went less than? What if I have to be to the left of my black and to the left of my green? It has to be both. It has to be black and green. What would that be? Now be careful. I'm left of both. So this would be shaded here, and that would essentially be the whole circle. So wouldn't it be from pi over 3 to 5 pi over 3? And so what's my answer? 0, and then pi over 3, 5 pi over 3. Is that okay with everybody? If this had been, oops, Gabby.
Sorry, why is it not the area between 0 and like pi over 3?
Remember, if you're going to be positive, that means this times this has to be either both bigger than 0 or both less than 0. Okay? So if they have to both be bigger than 0, let's say, here are my two angles, then that means I would be looking at this right here. And then bigger than that, you can't be bigger than that. You can only be at that. So that point is the only thing that's pink and black, all right? Now, when I do the less than case, I'm less than my black line, so I'm, oh no, oh, hopefully, let's see. I told you that story, right?
You're right.
Yeah.
You're gonna be fine. That was like a second.
If I'm not here Tuesday, you'll know where I am. Teaching jail. Alright, so, yeah, I have to be to the left of my black line, so that would be this right here. Then I also have to be to the left of my green line. Now, that would be the whole circle. The problem is I have to be both, and the only part of it that's both is the black and green part. If I had been greater than black and less than green, then I would be shaded in there. All right, good deal. Which has a vertical asymptote at x equals pi. Do you remember what these are all secants and cosecants. Do you remember what those look like? The regular cosecant is the flip of the regular sign. So where does a regular, that's a regular cosecant, where does he have asymptotes? The regular cosecant has an asymptote at 0, pi, and 2 pi. All right, let's look at our cosecant answers. If you look at C, if you shifted the cosecant pi over 2 to the right, would you still have an asymptote at pi? No, so it's not C. If you took the cosecant and you changed its period, okay, now changing the period, we're going to divide by a half, which is timesing by 2. So now the asymptotes would still be at 0, but now they'd be at 2 pi and 4 pi, not D either. So it must be one of the secant answers. So let's look at what a secant looks like. A secant is the reciprocal of the regular cosine. So it has an asymptote at pi over 2 and an asymptote at 3 pi over 2. That's what your secant looks like, or cosecant. This is the secant. Okay? Now, if we took, well, does that have an asymptote at pi? No. So it's not A. What does B say? If you took this picture and shifted it to the right, pi over 2, would there be an asymptote at pi? Yeah. So the answer is B. Okay, now we have a proof. Take a look at it. What do you think might be a way to start this proof? Anybody have a thought?
Jamie, cross, more, cross.
Okay, now wait a second. Let's talk about that for a second. So we are proving, and what that means is we are going to mess around on this side and do stuff to it, and eventually it's going to come out to be this side. So, okay, so basically, this side is untouchable, Enzo. This is what I want to end up equaling. It's like in geometry that you prove, okay? So, yeah, I got to do something over here. My gut feeling when I first kind of just glanced at it was, okay, we'll factor. Oops, what's wrong with this factoring? That's a cosine, right? And there's no way to factor a cosine and end up with a sine in the middle. You know what to do. What do we know about cosine squared? What's cosine squared?
Doesn't it equal 1 minus sine
It
squared?
does. It does. Very good, Cole. Sine squared plus cosine squared is 1. So that means that cosine squared is 1 minus sine squared. Can I do the same thing in the bottom? Why would it make sense to do that in the bottom? What are you ending up with? Sines, right? I don't want cosines. I don't want to end up with cosines, so I'm going to change them all. So 3 minus 3 sine squared plus 5 sine minus 5. Does anything happen in the numerator? Can I clean that up at all?
You can combine the 3 and the -5.
Yeah, so I can factor, or I can collect my terms, and then hopefully factor that. So I'm gonna have, now let's see, it's kind of backwards. I'm gonna have -3 sine squared plus 5 sine minus 2. Now I'm going to try to factor the top. Now I have a confession to make. I have a heck of a time factoring when that's negative. I do not like to have that be negative. Now you may be better at it than I was. You probably had a good first year algebra teacher, so you can probably do it. I'm going to go ahead and take out a negative. I can't drop it. I can't lose it. But I'm going to take it out to give myself, this is my personal problem, it doesn't need to be yours, but I'm not gonna be able to factor that. It's gonna take me a long time and I don't wanna mess with it. So I'm gonna pull that negative out, keep it in the problem. It's gonna show up in the answer somewhere. I'm gonna keep it out, and then I'm going to factor here. So let's see, 3 sine, sine, that doesn't work. I think that works. Remember, I'm factoring what's in the parentheses, the negative's out.
And then could you put the negative down on the bottom?
I can put the negative anywhere I want it. Let's talk about that. I'm gonna factor the bottom, 1 minus sine, 1 plus sine. Now, do these two cancel? These two right here.
Well, it's with the negative.
They can with a negative, that's exactly right, because it's like canceling x minus y and y minus x. They are the same thing, just opposites of each other. It's like 7 over -7. They'll cancel, but they leave you with a -1. Well, guess what? I got one right here. So that and that and that are all going to cancel, because these two are opposites and leave me with a negative that will cancel with that negative. And lo and behold, that's what we wanted. Don't you feel great when that happens? When it all works out? It just makes you so happy. You all look delighted. All right, next, we're almost done with this paper. cosine 2x equals cosine x. All right, so here we go. You have a thought on that?
You're gonna change cosine 2x,
We're gonna change cosine 2x, what are you gonna change it into?
cosine x squared, or cosine squared x, sine x.
So, this one is a little bit tough because
Oh, that's what you're gonna do.
it is in three forms. So your versions for cosine 2x are cosine squared minus sine squared, 2 cosine squared minus 1, and 1 minus 2 sine squared. These are all ways to rewrite cosine 2x. So step 1, does everybody understand the need to rewrite that? You can't do the problem with a 2x on this side and a 1x on that side. Won't work, okay? So we gotta rewrite that, and here are our options. Which would be the best option in this particular problem? The middle one. Because we already have a cosine. If we use this one or that one, we'd have to deal with sines. And now we have just cosine. Alright, so now what should I do? Now I've got it rewritten.
Divide by 2, or wait, add over the 1.
Add over the, or subtract over the cosine. Because isn't this quadratic? And I always want to get my quadratics equal to 0, right? Hmm? So factors like this, go like factor like this. So 2 cosine and cosine. And I gotta figure out. So this is not an inequality, so I only need my angles close to the other problem we did, but not quite. Where does the cosine equal negative 1/2?
2 pi
Over
3,
here.
4 pi over 3.
2 pi over 3 and 4 pi over 3? And where does the cosine equal 1? At 0. Is that okay with everybody? All right, the last 3, it looks like are polar graphs. So take a minute with your partner and see if you can hash these out. And run revision. No calculator. No calculator allowed. Try to do it without a calculator.
Yeah, I think
No calculator. Don't want drama in your life, so we have
Ends up problem with girls.
a problem with girls.
Yeah, she's a little sophomore. Problem or obsession?
I got
Ooh, we don't be obsessed.
It's bad.
Why does she love you so much?
I don't love myself that much.
I don't say that. Restricted.
Or wait,
yeah.
lines from flat. Oh, you says restricted from pi over 2 pi, so that's quadrant 2, right? No, I don't. Because anyway, out of the 4 here, I look for least like fixing
No.
It's 4 pounds.
Wait, is E to B?
No, it starts on the A. It does.
It'd go from
It's
start to
E, it's, yeah, I think it is E to A.
Oh, you guys already passed.
Oh, yes.
Because if it starts here, wait, I feel like your logic is out. So 0 to pi raised to 4, and this right, pi raised to 3 pi.
B.
Right, this is a cosine, cosine starts here.
It's either A or B.
That makes sense.
You don't know what it is.
It's C or D. Like you said 0 to pi over 2, I would have gone.
No, no.
Try to see closer together.
I thought this was.
Okay, so there's 4 cosine 2 of 3. So it's gonna reach the 4. Okay, we can logic that. It reaches
D is the point straight down, E is the
How is it?
So, oh, and C is the point straight down.
Like, that's all I want to do.
It's cosine, it automatically knows.
Come on, we're doing all 3 of these guys, let's stay focused.
So we know, yeah, 4 petals.
It'd be B or A. I don't know. It's B or A. This part is 3 bigger than 5.
Yeah.
Probably.
And that would be the sine if it was.
Wait, hold on,
So
wait.
if you look at these, this one looks like how you these both are.
Yeah, it is, because cosine is.
I'm actually fine with the same because of the sine. Well, I do the way that
Wait, so what are we doing? No, not chat. We're doing as you see, this
Yeah,
Alright, so hold on, first off, wait,
That right
it's
there.
either C or D, just let me
Subtract
look.
5, it's that point right there.
Okay.
Yeah, that point we don't
So
have.
there's gonna be 3 petals. This is that.
We'll know that if it's
Four, there's just one number out in front of the cosine, and this is gonna be a flower, right?
I get these problems great a lot of the time.
Even number,
I
then you can
don't know why.
four petals. If you look at the
I
graph.
get them all right, I just don't know why.
Yeah, and it knocks you down to B or no, C or D. No, you know it's gonna be a flower, and if you're looking at line 2, because it is, line 2, you're looking at just that part of the graph, and if it's a flower, you look at that, and so it'd be either C or D. And I don't know which one, because B is a flower. It could be, but cosine squared. Let's choose C or D. Wait, no, it is.
Cosine starts at 0.
It's B.
Oh, so it's
I
not
knew it was B. I just He's not worried about it. I know, there's just one number in front of it left.
What is the negative?
But it's the negative.
There's no in there.
So-
What's this negative? You just finished the shape.
I've heard the quiz was kind of easy, but I didn't take it yet.
It's like the true or false stuff they were doing before. Like,
I
are
don't
you
know
on
that.
that?
I don't like, I'm not really.
18 is this one.
18C.
I think so.
Well, yeah, I'm gonna study some of their
Yeah.
practices. I'm not worried about it.
No, it's D.
Yeah,
It's D.
I don't know, I don't get it.
Well, no, it's just like, it's in the notes.
Oh, it's in the,
Yeah,
it's fine.
there's just 4 pages like in the back that were featured through science.
That's
Is that what you guys did?
That's what we did during class, takes certain questions.
It's a negative.
Well, No, but I feel like that's.
She didn't see if it was
Oh, she did,
positive.
yeah, that's right.
Yeah, she had told us before.
Yeah, like the, cause it's kind of.
So I was.
Oh, wait,
So
You know, you can do that.
if it was just, okay, three signs or three signs.
Cause sign always tickles the y-axis.
No, it's.
She like copies. She told us that she was like, she copied us. OCP design.
They gotta be two five or three apart.
Alright, we getting close to getting done?
No, because it always.
What's the matter?
They're all 2 pi over 3 apart.
I'm going back.
Which one? Why?
It's a great question. I really like that. I don't like anything. So I'm back.
Well, I don't know.
I was thinking of you because I saw the -3 and
Because cosine goes like here. This would be 3.
Well, okay,
That's what was making it for D.
Trying to actually do it.
Oh, cause here, look.
What's your boss? Taking it twice now. I don't know. I just prefer to tell me.
I'm gonna plug pi over 2. Which is the point right there. That says 3 is 3 pi over 2. Sine of 3 pi over 2. -1. -1 because -3 is 3. Or, yeah, -1 to -3 is positive 3.
So we don't like D or this?
You guys do.
D.
What were your 3 answers?
I got B, and D.
that actually is true. Yeah, and they're,
Oh, really?
they're right.
Well, I put pi over 2.
That's funny because I was saying C over here and they were all
The answer is, I'm
Look,
positive the
I-
answer is C, but don't ask me why.
Cole actually circled D on my paper and I was like,
He's
I don't
wrong.
think
I
it's D.
assure you he's wrong, but I
Alright,
can't
guys.
I'm really sure it was.
Alright, let's go, let's talk about these. Alright, so for 16, I got E to A as my answer. And my reasoning is kind of from the board, I plotted some points. So I knew I was only looking at this little part of the graph. So a pi over 2, I'm at -6. Well, where does that point get plotted? That gets plotted down here, doesn't it? Because the radius is negative,
Does it always go in that order?
because you're going around the circle. So however it graphs, it's going that way. Now, it might loop around, so it might end up down here, but it's going to be moving in that direction, the way of the circle. Okay, so then, so that made sense that I would start at D. And then when I put 3 pi over 4, it's 0. That brings me back to origin. So there's the piece that he said, D to E. So then I put in pi, which was the end of my interval, and I got 6. Well, where is that point plotted? That point's plotted right here. That's the point R is 6 when theta is pi. So it made sense that since I went from there to there, I would go from there to there. The next move would be to here, and then to here, and then to here, right? And then I have this part again in there. Oh, wait, I missed something. I'm sorry. No, I don't like that. Yep. So 4 is. All right, so I think the answer is B. All right, what did you do with 17? What did you think about that one?
Got D. The first time was here.
Be careful. With cosine, the first pedal isn't at the pole. Remember, because the cosine of 0 is 1. So the first pedal is going to be 4 times 1, which is a 4, not at the pole. Now, it goes through the pole. There'll be points at the pole, but not the first one. Does that make sense to you? Okay. So what is the right answer? Well, did anyone have any other thoughts on this?
Is it A?
Pi to 3 pi over 2.
Oh, it's
It's A.
Here's some A's. I got A. And I got A by plugging into my equation pi. When I plugged in pi, I got 4. So that point would be plotted right here. And then I plugged in 3 pi over 2, and I got negative 4. So that point would be plotted up here, negative r, plotted up here. So remember, we're connecting. So I got
Why would they add in a problem? Just gaslight.
Does that make sense? Actually, now that I did that, I'm wondering if I could have done that easier, but anyhow, those are the 2 points that I got when I plotted it. All right, and what about 18? What did you get for 18?
C.
C. And that one is probably the easiest one of all, because you know that the first tip of your rows is going to be where theta, or where your angle is pi over 2. Remember, the sine of pi over 2 is your max. So the maximum for this equation would have to happen where theta is pi over 6. Because that would make pi over 2. That would be the point, r comma theta would be the point negative 3 pi over 6. Where is negative 3 pi over 6 going to get plotted? 7 pi over 6. So you have to have a rose at 7 pi over 6, or a pedal at 7 pi over 6. And the only one there that does is C. All right, let's take care of homework stuff. You should have back all your homework papers that you gave me.
So the negative 3 doesn't matter.
What, you said something about what?
So the negative doesn't matter. Well, doesn't the negative make it face down though? Like I thought the negative made the first pedal face down.
The first one, oh, not straight down. No. Okay, stop and think. The only way it's gonna face straight down is if you put in pi over 2 or 3 pi over 2 and have a maximum. You see what I'm saying? And if you want it to go straight down, you're going to put in 3 pi over 2, right? Because that would be the straight down point. I need this, Alex, I need this to be pi over 2. That's how I get a maximum, or, my ends of my pedals on a sine happen at pi over 2 and 3 pi over 2. But that's not when theta equals pi over 2 or 3 pi over 2. It's when the angle equals 3 pi over 2. Or pi over 2, or pi over 2. Does that make sense to you? You gotta be careful, because when you look at the graph, you're looking at a theta value, but this is the key, it's 3 theta. It's not just plain theta. Is it emergency? You're thirsty? Hold on to that thought, you can go in a minute. All right, does anybody have any, homework things that I passed back that you have a question about? Yep,
Number 2 and 315.
315, number 2. All right, so this is I should say, average rate of change problem. We only have to use the average rate of change to make a prediction. So, first thing we're gonna do is find the average rate of change. All right, so let's get our formula up here, because that's what we always have. We do an average rate of change problem. pi over 3 minus pi over 6. Is everybody okay with that? Okay, so what f, you don't have to do any calculating, it's all right there. F of 2 pi over 3 is negative 2. F of pi over 6 is 5. And then getting a common denominator, that works out to be pi over 2, 3 6. So I have negative 7 over pi over 2, which would be negative 14 over pi. Would you agree with that? Now, that is the average rate of change. Now, you can do this a couple different ways, always, of course. When we did this before, we simply took these 2 points that we have and the slope, essentially the slope, and we wrote the equation of a line. So one option you have is to pick a point, maybe I'll pick that one. Y minus 5 equals negative 14 over pi times x minus pi over 6. So regular point slope, this is one option you have, regular point slope. This is the slope, I picked that point, plugged it in. So y minus 5 equals negative 14 over pi x plus 7/3. Keep an eye on my arithmetic, does that look okay? And then I'm going to add the 5 over, so negative 14 over pi x plus 22/3, 15/7. Now the question is, what happens at f of 5 pi over 4? Well, that's an x value, so it's going to be negative 14 over pi times 5 pi over 4 plus 22/3. All right, so those are going to cancel. That's going to cancel. So I have negative 35 halves plus 22/3. Keep an eye on my arithmetic. Does that seem right? So I get a common denominator. And I have negative 105 and 44. So negative 61/6 would be my answer. Okay?
Yeah, sorry.
Alright, who else had a question? This is straight out of Unit 1, straight out of Unit 1. It just involves trigonometry instead of regular x's and y's. Alex,
Use number 3.
on that same paper?
Yeah.
Alright, so. Okay, so my equation is negative 4 sine plus 2. So I'm going to take a look at it. Amplitude's 4, so that's 2. Up to 6, down to negative 2. No phase shift or period change, so it's a regular old sine curve. So Alex, are you kind of keeping up with me here as I'm rattling through this?
Yes.
Alright, so there's what it looks like. Now I am interested in the interval. Oh Lord. This, I have so, okay, let me see your homework paper. Did I make the change?
I have 3 minus.
I have, yeah, I have mistakes all over the place. So, yeah, you could be right. This is the problem I meant to have, and I did this earlier on a couple of things. I changed the problem and didn't change it on your copy. So, forget what you wrote, because I obviously changed the problem for a reason. Pretend this is your problem. Forget that I marked it wrong, make sure you know how to do it right. And then the interval is pi over 2, 5 pi over 6. Okay, that was the interval I wanted you to consider based on that equation, which was different than the equation you got. I'm sorry, that's 3 I have to fix. 3 problems. That I just need to fix. I'm sorry. All right, so let's back up and make sure now you are with me. So if this is my equation, Alex, which is totally different than your equation, are you okay with that picture? All right, here's my interval. So I'm looking, pi over 2 is right here, right? Now, 5 pi over 6, it's in here somewhere, but I'm not exactly sure where it is. And I have a point sitting right there that I'm a little curious about. So I'm gonna go ahead and figure out where this equals 0. Because I'd like to know what that point is. I'd like to know where 5 pi over 6 is relative to it. So I'm gonna set this equal to 0. And it looks like the sign is 1/2. So this point is actually 5 pi over 6. So now I'm looking at this interval right here. And what do I want to know? Is the distance from the origin increasing or decreasing? Look at this right here. Now the function is increasing, but the distance from the pole is actually decreasing because I'm getting closer to the x-axis. Okay, so I'm sorry, this problem was messed up. This is what we gotta understand. Does everybody understand what we just went through? Yeah. Okay, just draw an X through that problem because that was totally messed up. Okay, what else can I fix? Anything? Yep. On the same problem, number 4. Now, I didn't change anything here, so I'm hoping that it works out. So number 4 says do the same thing, but do it for the equation 2 cosine 2 theta. So 2 cosine 2 theta. We'll have a period of pi. Might have to go farther than that. So the first period, positive. So the first period is going to look like this. And then since my interval goes to 2 pi over 3, I'm going to go ahead and graph another period of it. So it goes forever, remember, it goes forever, so we can keep going. Okay, so there is my picture. Now the interval I'm interested in is pi over 2, or no, yeah, pi over 2, oh wait, maybe I didn't need to go that far, I guess I didn't, to 2 pi over 3. So pi over 2 is right here, and I'm going to 2 pi over 3. Yeah, that problem's messed up too. Because that interval from pi over 2 to 2 pi over 3, oh wait, no. 2 pi over 3 is here, isn't it? Yeah. So no, this problem actually works. So this interval right here is the one I'm looking at, Declan. So the curve itself is increasing. But what is happening to the distance to the x-axis? All right, anything else?
Is there like not a lot of
No, there's 2 minutes you can wait. All right, okay, let's take a look at the additional review. The additional review. I'm going to give you a little Easter homework here.
Oh, I'm just looking.
Oh, want you to practice these 14 problems. Now, the answers are posted. I don't have a key with me, I hope I didn't change any of these. Do these 14 problems, so that when you come to class next time, we'll have a place to start. Everybody got it? Okay, we're gonna do these 14 problems, the extra, are called additional review. Okay? We're gonna do these. So by the time you come to class, you'll have these done.
Will we still have points going into
There is
everything, right?
definitely basketball.
For what?
Like for homework, like points on
We're gonna have 400.
Okay.
It actually isn't gonna go into homework, because the new work you do is gonna go in a different category, because most kids right now have. When I put in another homework, they will help you, like I put in my category.
Not like sketch or something?